Okay, here are the 3-6 notes. You should have your 3-6 note packet, your 3-6 homework, and your textbooks open to page 195. We're going to be talking about proportional relationships in comparison to non-proportional relationships. We're still just dealing with lines, but we're going to see that there are different kinds of lines. So these notes are short, so you need to be paying attention. Today is 10:30. Okay. If the relationship between the domain, or the x values, and range, which is our y values, of a relationship is linear, the relationship can be described by a linear equation. Basically, that means if it makes a line, you can rewrite it as a linear equation. If the equation is of the form y equals kx, we call this direct variation. This is from section 3.4. When k does not equal 0, then the relationship is proportional. Now, what we're going to see when we turn to the other side of our notes is you're going to have y equals kx plus or minus something. So if you just see y equals kx alone, then it is proportional. This equation's graph will always pass through the origin. We remember that from our 3.4 notes. And so direct variations are proportional relationships. Here's an example. We have y equals 3x. K is 3. That's also our slope. So I'm going to make a table of values. I'm going to say x and y, and I'm just going to pick 4 x values. I'm going to say -1, 0, 1, 2. So I have 3 times -1, which is -3. 0 times 3 is 0. 1 times 3 is 3, and 2 times 3 is 6. These are my ordered pairs. Okay, go ahead and we're going to draw on a graph. And I know that at -1, I'm at -3. At 0, I'm at 0. At 1, I'm at +3. 2, I'm at +6. Okay? Now, since we hand drew this in, it might not be very straight, but we're going to make it look as good as we can. So, yes, this is linear, and yes, it passes through the origin. This is proportional. Now, what that really means is that the difference between each term is the same, kind of like we were talking about in the sequences last time. So I know that between 0 and 1, I increase 1, and between 0 and 3, I increase 3. Between 1 and 2, I increase 1, and between 3 and 6, I increase 3. So if I'm talking about ratios for y to x, remember we're going to list y in the numerator because slope is rise over run. I'm going to start writing them as a fraction. So I'm going to say 2 compared to 6 is 3. 3 compared to 1 is 3. Now the only ordered pair in here that this does not apply to is the origin. 0 compared to 0, so 0 divided by 0, doesn't count because that's not going to give us 3. But if I talk about -3 over -1, I get 3. So when you're dealing with direct variation problems, you ignore the ordered pair 0, 0. It will never make this true. But for all the other terms, you should get the same proportion. Now let's turn to the back side of your notes. You're also going to turn the page in your book to page 196. Okay? Some linear equations can represent a non-proportional relationship. This is when the ratio of the x values, or the domain, to the value of y, which is also known as the range, is different for selected ordered pairs than on the line. Then the equation is a non-proportional and the graph will not pass through the origin. back here, it didn't matter what ordered pair we chose, we still got 3, except for 0, 0, and our line did pass through the origin. It is proportional. So over here, we're going to do an example. We're going to use, let's pick the points off of this graph. I'm going to list them like this. I'm going to put at 0, we're at, that's hard to see, I should have done a better job. Let's say 5. No, that's supposed to be at 6. If you're looking in your textbook on page 197 on example 2, that's the graph we're looking at. So the next one is 1, 9, 2, 12, 3, 15, 4, 18. And we're going to stop there. I think that's, I went up one more, but we're going to stop there on our line. So let's write out our ratios. I'm not passing through the origin, so that line or that rule doesn't apply to this example. I'm going to say y, so 6 over 0 is undefined. We can't do that. We cannot divide by 0. If I have 9 over 1, I just get 9. 12 over 2 gives me 6. 15 over 3 gives me 5. Do you see where I'm going with this? 18 over 4 can only be reduced to 9/2, or 4.5. So, yeah, it makes a line when I graph it, but it doesn't pass through the origin, and each set of ordered pairs has a ratio that is different from a different ordered pair on the line. They all fall on the same line, but they do not have a proportional increase. So that's why it's called a non-proportional relationship. If we were to write the equation for this line, it would look something like this, and we have not learned this yet, so don't be worried. We would have something like y equals 3x plus 6. So if we just had the 3x, y equals 3x, we would have our direct variation, which is proportional. But we don't. We have a plus 6. So that makes it non-proportional. That's the end of those notes. So that was short. You have your homework. You should work on those. If you have any questions, be sure to send me an email.